So we've talked quite a bit about interior angles. We're going to talk about exterior angles for a moment as well. And I'm going to go through and actually show you why the exterior angles do what they do. In the end, you kind of just need to memorize that last piece, but I think understanding where things come from can be hugely beneficial. So I'm going to go ahead and do that here. So first off, we need to actually look at what an exterior angle is. And what it is if we just make supplements to our interior angles here. So there's an example. And so if this one's A, then this one plus this one have to add up to 180 degrees, which means this one would have to be 180 minus A. And then we could go ahead and do that exact same thing for the rest of these. And it's probably useful just to mention that what I just said a moment ago is the exterior angles are supplements to the interior angles. So trying to figure out what this might end up adding up to, what we can do is first use the fact that since this particular polygon we know is a four-sided polygon, so it's going to have two triangles, I know that A plus B plus C plus D has to equal 180 times 2. 2 is the number of triangles when we use that vertex to vertex method. And so we can see here that A plus B plus C plus D has to equal 360 degrees. All right, well, that's all well and good, but we want to somehow relate that to those exterior angles then. And so what I'm going to do is I'm actually just going to take those exterior angles and I'm going to add them up. Cool, so what I'm going to do now is just kind of rearrange these slightly. So there's 4 of these 180 degrees. And then we have our negative A, negative B, negative C, and negative D. Now this part is probably the trickiest part of what we're doing, but I see here that these are all negative, and I know that A plus B plus C plus D equals 360. So what I'm going to do is actually just pull out this subtraction here and do some reverse distribution. And so now I'm subtracting everything that's in there, but now I have this nice statement of A plus B plus C plus D, which I know is just equal to 360 degrees. Hopefully you can see where I'm going with this now, because we know that this is 720 degrees, 720 degrees, and so the sum of the exterior angles is just equal to 360 degrees, or 720 minus 360. Okay, so with our interior angles, we notice that this changed. So while I figured this out for the quadrilateral here, I haven't yet figured it out for a general polygon, or I'll just call it an ingon. And this is kind of a normal notation. In here is the number of sides. All right, so what I'm going to do in this case is I'm actually going to mirror everything that I did in the previous example. So starting here, I'll call this kind of step 1, is that I figured out what all of the interior angles added up to. And so in this case, that'll just be A plus B plus C plus dot, dot, dot for as many sides as there are. And so that's for, there's going to be in angles because there are in sides. And then I know that that's just equal to, and this is where if you haven't figured out the relationship between the sides and the sum of the angles, this was a 4-sided figure and we ended up with 2 triangles. So it actually turns out that the number of triangles is always the number of sides minus 2 with a polygon. Okay, and so again, this is the number of triangles. And so then we just multiply the number of triangles times 180 degrees, since each one of those triangles has 180 degrees in it. So that's step number 1 here. And then step number 2 was figuring out the sum of those exterior angles. So finding the sum of the exterior angles, I'm going to do the exact same trick here, except I'm going to use that kind of ellipses there to show off the dot notation. So then I know that we're going to do this in times, because if there's in sides, there's going to be in angles as well. And so we're going to wind up with in of these 180 degrees, and then minus A minus B minus C dot 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 on forever, which again, I can rewrite as minus A plus B plus C plus dot 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 for as many angles as there happens to be. And I, of course, know that if I add up all of those, it's just equal to n minus 2 times 180 degrees. So I'm going to subtract that here, n minus 2 times 180 degrees. And then I have this part here. I'm just going to keep that. And now here's again where I'm hoping you can follow along, but it might be a little tricky. But the thing is here that basically we have in 180 degrees in the red part, and we have n minus 2 180 degrees in the green part. Well, this is 2 less. Well, if we have 2 less 180 degrees and we're subtracting here, that means we're going to end up with just 2 180 degrees, right? Think of this as being like 8 180 degrees and 6 180 degrees. If we subtract those, we wind up with 2 180 degrees. And that would be the same no matter what, since it's in and n minus 2. It's just 2 less here. And so what we end up proving here is that no matter how many sides there are, because we did this in general form, we did it as if there were in sides, we don't even know the number, we wind up with 360 degrees for that sum of our exterior angles.